Welcome to Unit 5, Topic 1. We're talking about functions. The definition of a function is a special relationship where each input has a single output, and we call those inputs the domain, and we call the output the range. Or another way is the domain is what goes in our x values, and the range is what comes out, the y values. So, I didn't erase here. I'm going to just erase quick. When we're looking at these, how do I tell if it's a function by looking at the graph? I'm going to use the vertical line test. So you're going to draw a line, a vertical line, and a function touches the line one time. Okay, if it touches more than one time, it's not a function. So when I'm looking at this, if I go to this teal one first, and I draw a vertical line anywhere, hopefully your vertical lines are a little straighter than mine, it only touches once. So yes, this is a function because it passed the vertical line test. Okay, but when I look at this blue one, anywhere I draw, it touches twice. So this one's a no because it fails the vertical line test. Okay, purple one, anywhere I draw, touches once. So this is a yes. And for this yellow, orange, whatever you want to call it, anywhere I draw here, it touches so many times I can't even count it. Okay, so this is a no. So if I asked you if something was a function and I gave you a picture, one way to decide is to do the vertical line test. Okay, what about if I give you an equation? Here's a hint. Okay, if you're looking at this equation, get the picture. Okay, a great way to do it is to get the picture. So maybe now you go to Desmos, okay, and you type in f of x. You don't have to type that part in. You type in 2, absolute value of x plus 6, and you get a graph that hopefully, if Mrs. Vogt can sketch it correctly, looks like this, and the vertex is here. And then you would do your vertical line test, just like before, okay? Looking at it, anywhere I draw a mostly vertical line for myself, I know that this is a function because it passes that vertical line test. How about if you just have ordered pairs? This is not a dot to dot. Or a connect the dots, if you will. Okay, this is literally just you plotting the dots. Over 2 up 5, over 3 up 6, over 4 up 7, over 5 up 8. Okay, you're not going to draw. Okay, those are just dots. But you do need to look and decide about the vertical line test. You need to look at it. Just touches once. Just touches once. Okay, so anywhere I draw, it does only touch once. Okay, so yes. Another way to think of this is like an XY table. So if I put all my X's down here, and all my Y's down here, okay? Oops, this should be a 5. Okay, notice that none of these repeat. And that's important because if I'm going to scroll up a little bit. If I look at one of these, check out this purple one, and I'm going to just assign this a point. I made those up just now though, but look at, my X's repeat and give me 2 different Y's. So we don't want those X's to repeat. So when we're back down here, like the X's, they don't repeat and they each map to their own Y. Okay, so another way to think about it is looking at it as a table, an XY table. But remember, you're not drawing these out. Okay, it's not a connect the dots. Okay, so here's where things get tricky. Domain and range. Okay, domain is the x values, what you put in. What can I put in? So you might ask yourself that question. What can I put into my function? Okay, you might also say, are there numbers I can't put in? And these are the questions I usually ask myself when I'm thinking this through. Can I put in numbers? And I'm looking at this x-axis. If the flashlight helps you, think of it a flashlight that you shine on the top and the bottom, and you maybe see a shadow. It hits your graph, okay? When I'm thinking of this, I think, if this was me, look, here's me, walking along the x-axis. Can I walk in this direction forever and ever and get an answer? If I put in this one here, would I get an answer? Well, yeah, because these arrows go up and up and up and up forever and ever and ever, right? Up and up and up, forever and ever and ever. Okay, so yes, I could walk forever and ever this way till infinity and beyond and get an answer. And I could walk this way on my x-axis forever and ever and ever and get an answer, okay? We call this, to negative infinity, we call this all real numbers. Okay, there's a math symbol for it. It looks like this. I would also accept this, all x's. Okay, that would be another good one. So any way you want to say that, yes, I could choose any x value and get an answer. Okay, there's nothing I can't put into this graph. But what can I get out? Okay, this is my out. Are there answers I can't get? Oops. And when I'm looking at this one, so now I'm going to walk along. Okay. Can I get y answers up, 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 up? Can I keep getting y answers? Well, it looks like it, right? Because I can go over and up, over and up. But when I start walking this way, I hit a dead end. I'm going to call this -4. I don't know really what it is. Whoops. Okay. I'm walking up and down my y-axis, and I notice I hit the bottom. Okay. Can I get, let's say this is y equals -5 down here. Can I get y equals -5 out of this graph? I can't. Okay, it bottoms out at -4. I cannot get any more answers than that. Okay, if I put in x equals 0, I get -4. If I put in an answer over here or an x over here, all of my things are going to be up, up, up. I can't get anything lower than -4. So in this case, my y, or my range, is all those y's greater than or equal to -4. Okay, let's look at this again. Another one. And I'm going to say that this equation is y equals 2. Okay, and I'm going to look at this a couple different ways. Okay, if I was standing here, you can think about your flashlight. Okay, does my flashlight shine, 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 shine? Okay, I kind of like that one. Or I kind of think if I'm walking on this, okay, and I wanted to be walking on the axis here, so let me put myself, okay. If I'm walking along here, which x's do I choose? If I choose this x, do I get an answer? Yes. If I choose this x, do I get an answer? Yes. If I choose this x, do I get an answer? Yes. So if I'm thinking of this, I could put in -100 somewhere over here, and I would get an answer. Okay. If I plug in 0, I get an answer. If I plug in 7, I get an answer. If I plug in pi, I get an answer. So hopefully you're noticing any number I choose over here, I can get an answer. That's not how you spell number. Okay? So I can put any number into this equation, y equals 2, and get out an answer. Okay? If I'm looking at the y's, what's my answer? I plug in -100, I get 2. I plug in 0, I get 2. I plug in 7, I get 2. Plug in pi, I get 2. No matter what, The only answer I get is 2. My range is y equals 2, and that matches my table 2. Okay, so one thing I do want to mention back up here is the domain and range of a set of numbers like this. And if I give you a set of numbers, then the domain is not all real numbers. It's the set of the numbers I gave you, the x values. And for range, it's the set of y values. Set of. Okay, so when I give you this set of numbers, a set of ordered pairs, the domain is those x points and the range is the y points. Okay, that's it for topic 1.